So it's 1 p.m. I propose to start this session of Index Conference. So welcome, ladies and gentlemen, for this Index session on dismantling and waste management today, which is organized by the French Société of Nuclear Energy, Sfen. So I am Philippe Derycke, working at the Decommissioning Waste Strategic Planning Division of Orano in Paris. And I have several years of experience in nuclear industry, in particular in the fuel cycle. I am currently responsible of the management of the D&D project of the Orano La Hague first reprocessing plant called the UP2-400, which has been closed in 2003 and is now in the decommission phase for more than 10 years. And I am pleased to share this webinar moderation together with Mr. Eric Cantrel from CA. So Eric, could you introduce yourself, please?
Thank you, Philippe. Good afternoon, everyone. So I'm Eric Cantrel. I'm currently Deputy Head of the R&D Service on Process Design and Integration at CA Marcoule. I have also about 25 years of experience in the field of rad waste treatment and decommissioning, among which 10 years at SCKCN in decontamination and cleanup, and a few years on the decommissioning of the UP1 plant facility at Marcoule site.
Okay, thank you very much. So this session is the last webinar of this Index 2022 series. It was made of 9 webinars since the beginning of the conference in last December. We had 6 working sessions, with 4 on plant life cycle and 2 on transversal topics, and also 3 other webinars, which are roundtables and the keynote. So during the different sessions of the conference, we have addressed the different phases of a lifetime of the nuclear facility. It means from design, simulation, manufacturing, construction, operation and maintenance, as well as the transversal topics such as safety, regulation and standard and so on. So today's session is now dedicated to the last phase of the lifetime of the nuclear facility, which is the dismantling phase. Moreover, we will also address the subjects of waste management during the second part of the session as a tech demo. So, sorry.
So today's session is organized as follows. From 1 to 3 p.m. we will have 4 presentations on practical case study, which will give you insight on various aspects of decommissioning and dismantling project. So we'll start first with a presentation from Cyclife, reporting on status and achievement of the Inno4Graph European project concerning the D&D of gas graphite cooled reactor. Then we will have a second presentation from Jacobs about the application of virtual engineering to optimize D&D project. Then we continue with another presentation on D&D of gas graphite reactor from Graphitec, which is focused on the optimization of the D&D scenario. And finally, a presentation from Atkins about the use of digital twins in D&D projects. Also, we'd like to remind you that a video with a tech demo is available online on the mobile app of the conference. This video has been prepared by Mr. Bonardel from AB5 Consulting. AB5 Consulting is a company located both in UK and France, and in particular, they have been developing an application to optimize the management of waste in D&D project, which means identification, sorting out, segregation of different materials as steel, aluminum, graphite, asbestos, and other kind of waste. You can access to this video at your convenience with the mobile apps of the conference.
Okay, thank you, Rick. So maybe some practical information about the conference. Basically, for each presentation, each speaker has to remain in the time slot of 15-20 minutes at a maximum, then enabling both Q&A for 5 minutes and other speaker to give the talk in a good condition. So also, as mentioned, during the presentation, you have the capability to ask questions by using the Slido button, the S button on Teams on the top of the screen. So you can use this as soon as you have a question. So you have invited, don't wait until the presentation ends. You have also the capability to rank the posted questions, so the moderator will then ask the question according to the ranking order. I will also to remind you that the webinar is registered, so you will have the replay available sooner for registered people and a little bit later on the Sfen YouTube channel.
So now it's time to start the session with the first presentation entitled Innovative Tool for Dismantling of Graphite Moderated Nuclear Reactor, the Inno4Graph project, which will be given by Ms. Bérangère Clere. Let me introduce you, Bérangère. Bérangère has a PhD in material science. She mainly works as research and innovation project manager in nuclear field. Since mid-2020, Bérangère joined the Cyclife digital solution company as project manager for European-funded project. Cyclife Solution developed a digital decision support tool called DEM+ for nuclear and provides some simulation studies. Since the beginning of 2022, she has taken the role of simulation project line manager for Cyclife Digital Solution, in addition to her initial position. Bérangère, the word is yours.
Thank you. Thank you, Eric, for this introduction. And so thank you also to give me the opportunity to present the work realized in the project Inno4Graph, as you said, for innovative tools for dismantling of graphite moderator nuclear reactors. So to present the project, first I propose to present the context, then the objectives and the main achievements with a focus on the digital contributions. And lastly, I will conclude and add a word on the perspectives. So the Horizon 2020 Inno4Graph project is an international collaborative project started in September 2020 for a 3 years period. It is aiming to address common challenges connected to the graphite retrieval operations by investigate innovative solutions both on physical tools and software. 13 entities from 5 different cities and ships are involved in the project. The Inno4Graph project has set up 5 scientific and technical objectives. The first one deals with the sharing of existing dismantling scenarios and the building of a multi-criteria analysis guide to challenge the scenarios by using 5 use cases: Latina in Italy, Ignalina in Lithuania, Vendeios in Spain, Chinon A2 and G1 both in France. The second objective concerns the building of a graphite database of existing physical properties and radiological inventory, and also the development of technology methodology to improve the knowledge of the graphite core state. Okay, sorry. The third objective is a focus on tool used in graphite break retrieval operation by the elaboration of innovative tools for dismantling of these reactors, a state-of-the-art of the standard tools for graphite retrieval and handling, and one of the main topics also is the non-standard tools development and feasibility studies. 4 non-standard tools are studied and developed by the partners, as presented just below, thanks to some illustrations. Then the fourth objective concerns the development of 10th bench for graphite bulk oxidation risk assessment during cutting operations, the design and building of a representative physical mock-up in the demonstrator of a part of the graphite stack, and the evaluation, optimization, and qualification operational dismantling tools and the final scenario. And then the last objective is linked to the use of the digital tool by performing 3D simulation of dismantling scenarios, thanks to 3D reconstruction of a graphite reactor use case and the use of the DEM+ for nuclear software in order to simulate the graphite retrieval operations from baseline and alternative scenarios, to provide results in terms of duration and waste production, and to demonstrate the scenario feasibility. Now, I propose to make a focus on the digital contribution. The digital contribution in the InnoForGraph project are mainly the use of the DEM+ for nuclear software in order to perform 3D simulation of dismantling scenarios, and the development of a software module dedicated to the graphite brick retrieval studies named DEM+ for nuclear graphite module. In addition, 3D simulations could be a tool for studies of feasibility, evaluation of innovative tools through thanks to the 3D simulation, and also thanks to the 3D reconstruction of the graphite reactor use case for DEM+, by using the 3D models and associated data, it allows to simulate some scenario of the graphite brick retrieval. So to perform these studies, the DEM+ for nuclear software is used. DEM+ is a decision support tool and simulation software based on real-time 3D technologies in support of nuclear operation. DEM+ allows to identify all worksite zone thanks to 3D dose mapping, calculate the real-time dose rate received by the avatar, and investigate alternative strategies thanks to the simulation. The project framework, a DEM+ module, has been developed. DEM+ for nuclear graphite module. Its aim is to capitalize and manage the graphite core data, to use, if needed, some external calculation models specific to the graphite brick retrieval by developing a specific connection with an external calculation models, and then facilitate the realization of some sensitivity studies. The 3D simulations allow to perform a feasibility evaluation of the innovative tools and methods. As an example, some 3D virtual tests are performed to assess feasibility of bricks retrieval and filling of the waste basket. These tests are performed with DEM+ software by Graphitech, as you can see an example here, from the Chino i2 Graphitech stack. In addition, some tests in simulation mode of the multi-zone manipulator tool designed by Ansaldo Nuclear for preliminary test design has been successfully simulated with DEM+, thanks to our support and cooperation. And to use all the capabilities of the software, the 3D models and their data in terms of mass, volume, have been provided and integrated in DEM+. As an example, some view here of the DEM+ of the several use cases studied are presented. You can see Vendaios, Chino A2, Latina G1, and Ignalina 1. This is from DEM+. And so each core reactor has some specificities, and all these specificities are visible in the 3D model. As for example, there is some different type of bricks, board and or plan bricks, different diameters, heights of the bricks, and also a possibility to have a staggered brick. Thanks to all this data, a baseline scenario has been proposed for each use case. And here, this is an example of the baseline scenario simulation of Chino A2 on D+. For this scenario, we have limited the perimeter to the graphite core with all types of bricks. The bricks are retrieved one by one by using the cobble, and the results are obtained in terms only in terms of planning and waste. To conclude, the ambition of the InnoForGraph project is to study innovative and physical digital tools to be used during the graphite reactor dismantling operation. This project is collecting an extensive knowledge on graphite properties associated with the tool that will be implemented to perform this process. And the digital tool contribute to provide some efficient evaluation of this innovative tool to optimize their development and recommend the most adapted scenario regarding the local context of each reactors, to evaluate some baseline scenario for graphite bricks retrieval and in perspective alternative scenario to simulate, and to provide results in terms of duration and waste estimates. And in perspectives, the industrial demonstrator in Chino, launched in 2022, allows and will allow to test new physical and digital tools, methods, and alternative decommissioning scenario in real industrial conditions. And thank you.
Thank you, Bérangère, for your presentation. It's time for question. I have here some question. Let me remind you that you can use the Slido button to ask your question and don't have to wait until the end of the presentation. The first question I have here is, do you foresee to couple other physics such as fluid dynamics for the dynamic containment and related potential risk assessment in case of failure?
Currently, we not consider all the dynamic calculation and integration of some dynamic containment fluid. Maybe we can use in the future, if you develop some calculation model, the link between the DEM plus module for the graphite and some external calculation in order to add more data in the simulation.
Okay. Another question is related to the possibility with DEM plus to study more complex scenario. And are there other alternative scenarios which have been studied and eventually benchmarked with this tool?
For the first question, yes, more detailed work and an example has been already performed and will be presented by in the following presentation by Paola Ontiveros from Graphitech about from point cloud optimal scenario with the use case of Chino M2 dismantling project. And about alternative scenarios, we are currently under definition with the project partners. We would like maybe investigate some modification of the type of waste per container by mixing all the type of bricks, for example, and we continue to discuss with partners, and we will test over scenarios.
Okay, very good. Last question, maybe concerning probably more detail on what the simulation exactly calculates. Maybe Albrecht, if you want to precise your question.
Yeah, thank you. I mean, very interesting. I mean, I was wondering, I understand that you mentioned that the simulation calculates cost implications and feasibility factors. Is that right? I mean, I was just wondering what exactly is simulated then.
Okay, in terms of accessibility, for example?
No, generally. I mean, what the simulation code actually simulates. I mean, what physics or what processes.
Okay. In terms of physics, we are focused on the radiological studies, for example. We can calculate the dose weight during an operation, and thanks to this, explore some different scenarios to optimize the dose weight received by the workers. We have also some results in terms of cost, of duration, to have a more precise planning, and also in terms of waste amount, for example. We can use for the feasibility study and anti-collision module in DEMPLUS in order to more identify what is possible to move if you want to test some robotical arm, for example. I think it's an overview of all the capabilities of the DEMPLUS software. If you have some other question for after, maybe.
Philippe, if we have time, there was a last question about what are the connection between Inno4Graph and Pleiad European projects, if there are any.
Currently, there are no real link between these two projects. We are in cooperation in order to exchange some information, some feedback. However, in the case of Cyclife Digital Solution, we are also a partner in the Kyrieleis project. And so we will work with this project. And DEMPLUS is one of the modules considered to be integrated to the platform.
Thank you very much. If there are no additional questions, I propose we go to the second presentation.
Thank you.
Okay, thank you very much. So I propose to move to the second presentation. The second presentation is, the title is Virtual Engineering Framework and Application to Advanced Decommissioning by Albrecht Kyrieleis. So Albrecht has a PhD in physics and has worked for 3 years here at the University of Manchester in UK in particle physics research, and then he moved into the nuclear sector, leading the development of computer tomography methods for material characterization. And now he joins Jacobs. So over the past 15 years, he developed an expertise in radiation transport simulation, nuclear physics, criticality, and safety, and also contributed to the broad variety of software development projects. And since 2017, Albrecht is involved in a digital twin and robotics application in Jacobs. So Albrecht, the floor is yours.
Yeah, thank you very much. Let's share. Is that visible okay? Is that visible okay?
Not yet.
Not
Okay.
yet.
Oh, all right. And that should be visible now.
Yes.
Yes.
Okay. All right. Thank you very much for opportunity to present. So yeah, this presentation will be on developments we have carried out at Jacobs into a virtual engineering framework, and particularly focusing in on some applications in the area of I'd call it advanced decommissioning. So this project that kind of underlies this work is the so-called NVAC project, so Nuclear Virtual Engineering Capability Project. I will provide a bit of an overview of that project before then looking at one of the applications which we did into a decommissioning case, and finalize then with a further area which we are currently working on, which is the digital mockup for remote operations. So NVAC in a nutshell was a program that ran over 4 years, was sponsored by the UK government, and effectively had the overarching aims to overcome silo practices across the sector, to improve information sharing and handover, and also to increase innovation and allow a cultural change in the way people work. Also looked at better cost management, and we were basically looking at achieving this through the development of an open framework architecture for collaboration. So there was a large element of the digital technology development or using technologies to support this, but also a large fraction of looking into ways in which one can improve collaboration. Now, very briefly, the scope really encompassed the entire life cycle of nuclear facilities with the large variety of aspects around it that have to do with information management generally and simulations. So this environment, which we then looked and started to develop, well, had these three main columns of the data environment, a modeling environment, and also the inclusion of standards for virtual engineering, allowing a range of key elements, such as this single source of truth, which is seen as a very key element, secure sharing of information, the integration of analysis tools, and ultimately also to enable digital twin solutions. To that end, we developed a very basic and very generic architecture, which has been progressed to a bit more of a first implementation stage, so a bit further than a prototype application, but not to a point where it's commercially ready yet. This system consisted of what we call the data system to handle any data that are involved in a project, the execution system to handle any of the codes that one might want to use for any simulations, and a user interface. Now, this whole project is a collaborative project which involved a range of companies as listed at the right bottom there. Now, to stress, this architecture was entirely generic and therefore agnostic to any application. And as part of that project, we applied this architecture to a range of application cases. With a little bit further details into these architectures, so basically this data system on the left was there to enable the link of data sources of various types and across organizations. And the execution system on the right was there to make possible the link of generic and multiple simulation codes, again, across organizations. The particular integration of a code would be achieved by the implementation of what we called adapters to realize the particular interface to that code. The execution system itself would be independent of the codes. So with that, I'd like to focus on to one of our application cases, which was linked to the so-called Integration Innovation for Nuclear Decommissioning, which is has been a competition project a few years ago, where Jacobs saved its place, and the ambition was to develop innovative methods for an agile way to decommissioning. And a key element of this project from Jacobs' side was the development and use of a robot with 3D cameras on and radiation sensors, including a Compton camera, which would explore the unknown area to gather a point cloud of space, but also in terms of chemistry and radiation levels. Linked to that was a digital platform called the Sixth Sense platform, which makes available the data collected to various stakeholders that contributed and are involved in the planning of that decommissioning process. Now, a very relatively simple and well-defined scenario was used to make an application of this NVAC framework, which relatively simply was the case that the robot couldn't reach certain areas of a decommissioning site, and therefore couldn't provide measurements across the whole site. But of course, it would be highly useful in many cases to have measurements and information across the site. So the solution would be to use the identified sources and calculate radiation levels using a simulation. And that constituted the application case. So we used this architecture to integrate the Jacobs radiation transport code MacBand, which calculates accurately dose rate levels based on a given geometry. And this geometry would first have to be derived from the gathered point cloud, and then the radiation map would be transferred back to that Sixth Sense platform and was then overlaid with the 3D view of the operators and the stakeholders that are involved in the planning. So in this way, the code or the application augmented this planning process. And of course, this also demonstrated that various others code could be integrated in this way to provide additional information supporting the decommissioning process. So that was one of the applications of the NVAC system to a decommissioning case. Now, I think hopefully has become reasonably clear that NVAC is relatively, or is very, very generic, and is also focused on increasing efficiency and collaboration. One area which is increasingly used in the nuclear sector is, of course, the remote operations with significant funding in the UK. And one of the departments in the UK is RACE, as part of UK AEA, the UK Atomic Energy Authority. And they have issued or started the project called LONG-OPS, which stands for long reach operations for long reach robotic solutions for long-term operations. And this project, we're working on several tasks. And as I will show in the next couple of slides, the NVAC approach and software is highly relevant for this project. So a few more bits on that project then. So the aim is to enable and particularly to de-risk operations over many years to come in shielded spaces with hazardous material. And as a core of this program was the development of what was called a next generation digital mock-up for the de-risking. And here's a picture of the different elements. The key stakeholders are the Nuclear Decommissioning Agency in the UK, UKAEA and TEPCO. So the key cases here are the decommissioning at Sellafield site in the UK, the maintenance and decommissioning of the jet fusion reactor in the UK, and the decommissioning of Fukushima. So focusing on two of these cases, just outlined here the characteristics of these application cases. So for JET, the fusion tokamak, there is typically a very low or reasonably low radiation environment. Geometries are usually very well known, and one is after the detection of objects and inspection and removal of objects. Whereas in Fukushima, we have a high radiation environment, partially underwater conditions, and often the geometry and the surroundings are not very well known and need to be explored. So this digital mock-up of remote operations, just what is it? Well, if one wants to carry out such a remote operation, typical steps would be to, first of all, define the task that should be done, as depicted here on the right, then to develop the actual sequence of steps, go through where the robot, for example, should go, what tool to use, what to do when, and what to do then, and to specify that sequence and get it approved by responsible people. Then we would want an operator to rehearse that process in a digital environment, and that would be done in that mock-up solution. Finally, then one would execute it in the real environment, and in the end review this whole process to learn from it. Now, this process is enabled through that digital mock-up, which is roughly structured like this. So we would have planning tools available, interactive visualization and simulations for the engineer to interact with. And that could either be interaction with the virtual system, or it could be interaction with the real robotics kit. Now, there would not only be the operators here, but also the planners of the operations, the approvers of the operations. So it is a much wider system than just the operation of the robots. And therefore, there is a range of functionality what would want to have in there, obviously from visualization and robot human-machine interfaces, and robot simulators, but also to path planning and physics simulation tools, operational management tools, such as these mission tasks and task planning, model management, and also equipment management. And then also further out, object detection, fault and noise generation in the virtual environment, for example. So there's a range of functionality that one would ultimately want to have in this environment. A key requirement was this to be flexible and extensible, and as a result also to be modular. Now, such a DMU would enable operation in very unstructured environments and support the agile development of remote operations. The supply chain would feed into this, and one would be able to allow competition and enable innovation. Also, it would allow suppliers of robotic kit to provide digital models, which then can be tested in these environments. And one could even pose challenges of engineering challenges that could be, for which solutions could be provided within this environment. So as part of this project, Jacobs partnered up with two other companies, MTC and PA, and we developed, first of all, the business case for that DMU that would drive the actual activities in the development. And one of that was the assessment of role profiles, so people who would interact with the system, such as the operational owner, planner, configuration developers, the operators themselves, but also reviewers. And one of the main activities was then to develop a software architecture for the system. And one part of it, obviously, is the perception pipeline of the robotics element or robotics part of it. So the control of the robots, the visualization of the virtual robot and of the cameras and the different sensors that the robot would typically be equipped with, and that would have to be on a robotics specific and fast infrastructure. Whereas there was a lot of other things around this, as I mentioned, such as the planning and management tools, and also semi-static simulation calculations that, for example, provide a generic radiation background for a virtual scenario. And all of these would be integrated in more an NVAC, I call it type environment, similar to what we have used this NVAC framework before, where there are not that high requirements to the frequency. And this combined architecture links these two different frequency architectures together to provide a full environment. Now, ongoing activities are the actual implementation and development of novel methods for the robotics side of that infrastructure. So the linking of sensors and simulated sensors over processing tools to the data fusion and integration of augmentation methods, object detection methods, for example, through to the visualization in a way that is suitable to operators. So that is ongoing, as well as a work package in which we work on the development of training data for machine learning that ultimately will be used to detect objects, for example, in the jet tokamak, but also scenarios, elements in the Fukushima environment, which are very different challenges because of simply of the condition that are there. So, in conclusion, the NVAC project has looked at ways to increase efficiency in the work in the delivery of projects through collaboration and utilizing digital technologies. As a part of that, we have developed an initial version of a generic software environment and used it in different applications. One of them was for the integrated simulation in this advanced decommissioning project. And as a new project, the LongOps project looks at the de-risking of operations using robotics and using this next generation DMU with focus on Fukushima jet and Sellafield. Now, the emphasis there is on the development of an environment that allows the agile development of operations, collaboration across supply chain, and innovation. And Jacobs and partners are in the middle of ongoing activities to support this program. And overall, I think there are exciting developments and opportunities in this area. Thank you very much.
Okay, thank you very much, Helmut. It was very exciting. In fact, I have been also involved in Fukushima issues several years ago. So I have a personal question. You are talking about investigation, measurement, simulation in underwater condition. What are the specific constraints in such environment of underwater to use this kind of tool?
Well, one of them is clearly the visibility, and therefore the usage of the data for further analysis, such as recognition of any known objects, such as identification of passages that are traversable for the robot, but also potentially the safety of such operations, which could be where this water condition could be a problem. Other obstacles or barriers are simply the high levels of radiation, which require particular sensor solutions and electronic solutions if they sit with the robot. So I think these are the main things. Also, perhaps that one would be forced to have quite a long distance between the operator and the robot itself. Typically, it would be quite a long way to go in there. I think these are the main challenges, actually.
Yeah. Okay, thank you. So you have a question from Jean-Bernard. Can we consider NVAC architecture as an example of a data aggregator dedicated to D&D?
I wouldn't think it's dedicated to D&D because it's in fact entirely generic. So there's no physics in NVAC at all. In the original framework architecture, it's software elements that allow you to link together generic pieces of data with generic simulations and a flexible web UI. And the simulations don't even have to do anything to do with nuclear, and the data could be anything as long as you provide the correct or implement the corresponding interfaces. So decommissioning is one of the big areas we looked in, but it has also been applied, for example, in collaboration with EDF Energy for the assessment of graphite degradation over the lifetime for the AGRs, and chaining together specific tools that have been developed by EDF for that purpose. So, and another application was on the manufacturing sector, where we looked at the development of a component digital twin that had undergone a range of manufacturing steps. So, yeah, it is not specific to a certain area.
Okay, thank you very much. Another question, do we have the purpose of sharing your standards or to propose them to any normalization commission?
I think the standards are very powerful and important. We have, with this project, not got to a point that we have suggested certain standards or even released any kind of version of such standards. So we have sort of kicked off that process in this area, and with partners we work together in that project in view of continuing with that, so that one will ultimately end up with corresponding standards. So that is the status with that.
Okay, and another question, because during the presentation you explained that this kind of tool you can extend the collaboration with different stakeholders in the project. Could you also consider to use the tools NVAC to exchange information with the regulator?
Well, that's a very interesting point, and we had discussions with the regulator during the project. In principle, the regulator could be linked into that architecture, which would, for example, manage all information around a safety case, and would include potentially all or a large fraction of simulation tools that have been used in support of the safety case. And one idea is that in this way, the regulator could have very easy access to the audit trail, or the entire safety case could be much more transparent when all the data is managed through that system. In this sense, it would make a lot of sense, and we have started discussion with the UK regulator on that. One point, though, to mention as well is, I think that, yeah, the regulator in the UK will not repeat rigorously every step, every calculation. So there wouldn't be the need to make that possible, so to say. So it is probably mainly access to a well-managed set of information underlying the safety case that would be most useful.
Okay, thank you very much. I think that's all for the question. So I think we can move to the next presentation. So thank you very much, Albrecht, for this very interesting presentation. Thank you. Eric?
Thank you. So the next presentation is entitled From Point Cloud to Optimized Scenario, Use Case of the Chino A2 Dismantling Project, and will be given by Paola Ontiveros from Graphitech. Paola has a master's degree in dismantling and waste management of nuclear facility from Paris-Saclay University. Right after the master program, she joined Cyclife Digital Solution as a junior D&D engineer, where she worked at the dismantling of some French reactors, Chino A2, BG1. as well as other small CEA and EDF nuclear and storage facility. After 4 years of serving at Cyclife, she joined her actual job at Graphitech as a simulation engineer. Since then, she worked on simulating graphite reactor dismantling scenario, such as Chinon A2 and Saint Laurent A1. She's also been working on cost estimation, waste management, dose assessment, and planning of decommissioning projects. Paola, the virtual floor is yours.
Thank you very much, Eric. Well, I will begin with the presentation. Great. Good. I will be presenting these 4 points. I will give you just a small overview of the company. And then I will present you all of the projects that we've been working with about Chinon, all of the stimulation that we've been working with, and then a small feedback and conclusions. About Cyclife, well, as you can see here, Cyclife Group is part of the Department of the Construction and Waste Management of EDF. Cyclife has become a key player with an European platform in the field. And Graphitech, where I work, is part of this group Cyclife, as well as Cyclife Digital Solution that has already made a presentation before. So as you can see, we are 10 companies and we are present in different countries in UK, Sweden, and France. So I wanted to show a little more in detail the industrial demonstrator. It's a demonstrator. It's a facility of 2,500 square meters. It has begun its operations the last year. So today we have already been working in this facility. As it was said before, it's a facility where we make physical tests. But we also make a digital test of the tools that Graphitech we've been designing. So here you can see some pictures, and one of the latest tests that has been done is the one related to the project Ignofograph about the retrieval of the different type of bricks of Chinon A2. So about the project, well, the first thing that we made in order to begin the project, well, it was like years ago, was to recreate the facility in a virtual way. So we started from the point cloud representation of the facility. We took that and we were able to use it for like as an input for different software. So you can see here, I show you my survey software. It's a software that allows to have a virtual tour of the facility by taking the point cloud from one side, but also the high resolution pictures of the facility. So in the case of the Chinon A2 reactor, of course, we are not going to have pictures of the core, but we have pictures of all of the rooms that are besides the core. And we also have access to different information, the 2D of the facility, and we have the real information. Then also from the point cloud, we were able to create a 3D model, digital twin, and the entire reactor of Chinon A2 was created, was built. And today we've been also designing some tools and equipment to assure the dismantling of Chinon A2 internals. These tools have been also created in 3D, so they were implemented and uploaded in the different software that we are using today at Graphitech. So in order to give you a little more detail about Chinois 2 reactor, you can see here some of the characteristics of this reactor. As you may know, it was a reactor cooled by carbon dioxide. And here you can see that we are talking about a waste in graphite of more than 1,800 tons and 2,300 tons of steel. Here you see the dimension. It's a quite big reactor. And well, you have the total activity. We focus on the graphite. We have 82 terabecquerels calculated in 2026. So here, this picture was to show you that the complexity of the reactor is quite big. We have the upper structures where we have a slab, very thick slab of concrete that has to be open, and you see the internals. We have all of the channels that allow the control rods to be inserted, and also the fuel. So we have, you see the fuel channels and everything. And you see also the core of the reactor, and you can, that you can have the picture in your head. We have almost 20,000 bricks inside the core. So we have a lot of material inside the core, and the peripheral structures are most of them made of steel. So you can see the complexity of the project. Here is a comparison with PWR, so you can still see the size of this reactor. We are about 10 to 25 times the mass of a PWR, because as you can see in the picture, the core of the reactor that I just showed you, sorry, it's also connected to the heat exchangers. So this reactor had 4 heat exchangers. So we had a lot of metal included there too. So it's of course it's a technical challenge, and it's the first of this kind of reactor to be dismantled in the world. Today, the current work that we are doing in Graphitech is to optimize the scenario of the baseline scenario of Chinois 2 dismantling, and we've been simulating this scenario with using them plus for nuclear software that was already presented before too, and we're still working in the design of the tools that we are going to use to reach our objectives, and we are already testing these tools in the industrial demonstrator. Then the test of the implementation of different design tools in the digital environment. We also use another softwares besides them plus to do this, and all of the information that we get from all of the all of the tests, they are capitalized in the software and them plus, so we can use it, reuse the models that we create for the different steps that we are going to follow in the next phases of the work. About the phasing of the scenario, the scenario today is made of 8 phases. You see here, it's an approach top to bottom. So we are going to open the the concrete slab that is in the upper part of the reactor. Then we will be able to access to the internals. But before that, there is a phase. There's a very important phase. Is the installation of a platform that will allow to perform the operations inside the core without exposing people. So everything will be remote operated. And then we will go going to the bottom till we finish the dismantling. And well, we use DOM+ for nuclear to do the simulation. So this is a software that is helping us to do the decision of the different scenarios that we are proposing. And the software said before allows us to obtain the cost of the project, the dosimetry, the dose. We can make a dose assessment because the software actually has an activity engine that allows to calculate the dose. Sorry. By the straight attenuation of the rates. So it helps us today to perform our work, to have an estimation. Of course, it's not sure, but we take the information from different calculations and we input to the software in order to obtain the view of the dosimetry. Then it also allows us to obtain the planning and the waste, the quantity of waste and the conditioning of the waste. Here we can see, we'll see a little more about the simulation of the reactor. So about the digital input data. So as I said before, the 3D scan is exploited with the software My Survey, where we can input some more information. If we wish, we can add some virtual objects. Then we have the 3D model. Here we can see the CAD view of the reactor and the integration of the different tools. And with all of this information and all of the information that we can add to the software DOM+, we were able to do the simulation, and today we are still feeding the software in order to update the scenario. Today, actually, we made a focus on the upper slab because some tests were also made. So today we have the whole inventory of the reactor in the software. And we also are feeding the software with information of some models. When I say models, they are models that allows us to calculate the duration of each operation. So this information we will take from the tests that are being performed at the demonstrator. And finally, we will be able to get the results of each operation. So we get the collective dose, we get the time, we get the quantity of waste produced. And then about the radiation, we can also obtain the radiological mapping and the dose rate at real time. We are also making a lot of tests with the digital tools that we've been designing. Here is just a small example of the retrieval of the the bricks of the reactor. So we are able to configure the right movement of the robots that we are going to use, and to have the best approach with the software, so we can show the principle of the operation to different stakeholders. And finally, we can obtain the planning of the project and the global results with the detailed results of the project. Well, and to finish, well, today we were able to complete the baseline scenario using the software, and we will also able to identify some gaps and missing data and inconsistencies that we found in the information in the documents that we were using in order to work in this project. And as you saw, we are still working with the software in order to optimize and in order to capitalize all of the information. Some of the things that some of the gaps that we were able to find were, for example, the missing equipment inside the reactor vessel, some elements that were not cut, or some tools that were not placed in the right place. And well, all of the information that we are able to produce in the industrial demonstrator will also be capitalized in the software. So every time a test is performed on the demonstrator, we obtain for example, the speed of cutting of a piece of our element of the reactor. That information will be stored in our database. So, as a conclusion, the development of the 3D model from cloud points allowed us to have the virtual visit, the virtual view that I just showed you, and to make all of the studies and the simulations. The data and the feedback created was easier to access to all of the stakeholders of the project. So today we can share all of this information and we can make understand the principle that we want to show in a easier way. Then the optimization and the sensitivity analysis is also easier to handle and test. The development of new models and to estimate the duration of tasks according to the tools to be used and tests to be performed, and the optionering studies to find the best solution and the best scenario. So we continue with all of this cycle of optimization, and we are focusing this year about the internals of the reactor, and especially in the simulation of the retrieval of the bricks of the reactor. So that would be it. Thank you very much.
Thank you, Paola, for this very interesting presentation on a quite challenging project. I have here some few questions. One from Philippe regarding cost assessment. If you could you please maybe develop about the benefits of the simulation tool on project cost assessment?
Yeah. Sure. When we use this kind of tool, the first thing that we are going to do is to mitigate risks. So at the end, if we want to talk about cost, of course, we're going to win in using this kind of tools, because as you saw, we can represent the whole facility. We can have a virtual view of all the real facilities, so we can detect better the risks of the project.
And maybe what other scenario have you been studying and probably rejected then?
Other
Briefly.
simulations, well, there's been some project with the reactor of Budget, and then Saint Laurent in France, and big projects like Chinois 2, I think it's the first like that. Then there are a lot of small projects from the CEA. There's also a project that we are going to begin, I think, with the CEA. With this, but it's not a big reactor. It's the G1 and G2 and G3 reactors, if I'm not mistaken. But the biggest project that we've worked with is Chinois 2.
Thank you. Another question from myself. Considering the large number of objects you told us about, maybe 20,000 bricks of graphite to be retrieved, do you consider now full remote control operation, or are you already studying the automation of this retrieval process?
Well, it's under studying. So today what we are doing is everything is remote control. So as I explained, there's a platform that is going to be installed. So what we are doing today is to see if we can retrieve more than one brick at once. So we are designing the right tool to do it.
Thank you. I have no other questions so far. Thank you very much, Philippe. I propose we pass to the next presentation.
Okay, thank you very much. Thank you, Paola. Thank you, Eric. So I propose now to move to the next presentation, which is the last one also. It is a presentation from Atkins. The title is Safer, Smarter on Schedule, How Digital Twins Are Transforming Decommissioning and Waste Management. It's presentation by George Waldman-Kelly. George is a digital technical support lead for the nuclear power business for the UK, Europe and Middle East regions within Atkins SNC-Lavalin. He is an experienced engineer with a specific focus on the use of new technologies and innovation to solve engineering problems in hazardous environment, in particular in nuclear power station in UK, either in operation or in other phases such as dismantling operation. And he has a specific experience on digital tools and applications such as laser scanning, GoPro camera, 360-degree, which allow to build a digital platform for a decommissioning project. So, George, the floor is yours.
Great, thank you very much. I'll just share my slides. Can you see those?
Yes, perfect.
Thank you very much. So yes, I'm going to be talking to you about how digital twins are transforming decommissioning and waste management. And I think lots of the previous speakers have obviously already talked about this to some extent as well. So I think that it's great to see that there's so much alignment between the different organisations. And so what are the challenges that we find decommissioning operators around the world facing today? Well, we're in an environment and an industry where fundamentally high standards and safety is paramount. All of the organisations that we work for all say that safety is absolutely key, and that's got to be the most important. And we also have the idea that we are working on legacy old facilities, and we need to provide confidence in the plans that we've got for how we're going to decommission these facilities and deal with the amount of waste, given the liability that exists. and giving people certainty on what that is, knowing that these projects are very, very expensive, they're going to take a long time, and they're very complex. And so therefore, the more that we can provide certainty on how we're going to deliver these and how decommissioning will take place, the better. The problem is as well is that these are facilities and these are environments that are complex, and often the information that we have is patchy and sometimes not present. And so therefore managing that information between multiple different organisations, defining who's going to be doing what and what sits within which scope is key. And obviously, we talk about, there's conventional safety, but there's also the fact that we are dealing with radioactive waste, and therefore understanding of the kind of volumes, how much there is, and what the characterisation of it is a key challenge that decommissioning operators face. So what does the decommissioning planning process look like at the moment? Well, as I've sort of alluded to, we've got pretty poor information. Lots of these facilities are 50 or 60 years old. And the first part of any project can be overwhelmingly just about finding information that might exist on old 2D drawings that are filed away in filing cabinets and maybe haven't been seen for many, many years. Sometimes those drawings don't exist. And therefore the amount of existing information we've got is poor. And in order to supplement that information, what we often have to do is get senior engineers or subject matter experts to actually go on site and collect that information, which is a time-consuming and expensive process. And even then, there might be areas of facilities, or there might be some features that are just not accessible. We can't understand what sits behind a certain door or what a certain object is made from. And so therefore we have to make assumptions, and that increases the cost and the schedule that we put together for decommissioning and dismantling. And then the plans that we generate and for the dismantling process have to happen a long time in advance of decommissioning and dismantling actually starting, and so therefore have to be based on kind of theoretical quantities and using experience, although there's not necessarily a huge amount of experience of doing this in past. And so therefore, again, that adds into those assumptions that are added in on cost and schedules. And all that relies on a workforce of people who are familiar with those facilities. They may have worked there for tens of years, for many, many years, and increasingly are getting to a point where they are retiring and leaving the workforce. And so therefore, we have a real issue with keeping that information and keeping an understanding of what those facilities are like and what exists there. And so the lessons that we've kind of learnt so far within a UK context, but this applies just as much in France and just as much with any other nuclear decommissioning facility around the world. We know that it's complex, and we know that it's multidisciplinary. We have to interact with a lot of different groups and different people. We know that coordinating information between the multiple organisations that exist in that environment is difficult and needs to be improved. We know that at the moment we're maybe not as good at capturing the information requirements that we need to, i.e. people aren't necessarily getting the information they need in order to make accurate proposals and accurate estimations of cost and duration, and that's a bit of a barrier to collaborating between organisations. And we know that at the moment there is a little bit of almost empire building, where organisations perhaps are reluctant to hand over 3D models to the client, and so therefore relying on the legacy 2D information and not getting the most up-to-date information. And we find that lots of small organisations that are being brought in to help with specific features, whether they're demolition contractors dealing with scaffolding or asbestos removal or anything like that, maybe don't have a huge amount of nuclear expertise, but they need that information to be supported. And all of this is coupled with the fact that going back to information management and particularly in a UK context, the UK government did I think about 10 years ago, give a mandate to say that all projects and all of their estates should be operating at BIM level 2 by, I want to say, 2016. That is not the case. The industry has been very slow to adopt to that, and often those information management practices are still not in place, despite the fact that that's regular and commonplace in other sectors. And all of this builds to the idea we're talking about information, we're talking about sharing information between organisations, and we're talking about a sort of framework for storing and sharing and capturing information. And now we've heard the term digital twin a couple of times over the course of this call so far already, and lots of people have lots of different definitions of digital twins. And for the purposes of the rest of this presentation and for the work that we do at Atkins and SNC-Lavalin for our clients, we've put together a definition alongside the Institute of Engineering and Technology, which bases itself on a kind of level or staircase approach, where we start off with the idea of kind of baseline information at level 0. We're talking about reality capture data. We've heard people talking about point clouds, 360 imagery from GoPro cameras, UAV and drone survey output. So that baseline information that is an accurate representation of site. And then we move up the maturity level to start adding in the modeling information, 3D models, adding that information in so that we've got a kind of that 3D virtual mock-up. And then going up to level 2, where we start to incorporate metadata, and that becomes what we call the static digital twin, adding in a variety of different information in order to get it up to the next level of maturity. And those levels, level 0, 1 and 2, are kind of where, in many cases, we draw the boundary of the digital twin. These are decommissioning facilities, after all, which are going to be knocked down. And there's a question about whether it's actually valuable to develop a digital twin any further. Do we start to incorporate things like operational data and sensors? Do we start to have two-way control from those sensors? Or do we even use things like artificial intelligence and machine learning to autonomously operate those facilities? Well, maybe not. If it's going to be knocked down in 5 or 10 years' time, we can probably draw the boundary at level 2. So what do those levels mean? Well, level 0, we talked about baseline reality capture. That's 360 imagery. That's using SLAM laser scanners and to create point clouds, terrestrial laser scanning, flying drones, or getting robots to go and collect data for us. And it might not necessarily just be reality. It might be things like radiation mapping as well. And it's great that we capture that information, and anyone who's worked with a point cloud knows that that it's very useful, but they're large and they're cumbersome and they're difficult to work with. So can we get benefits out of it at the level 0 stage? Yeah, we can. And we do that using a platform called Cirrus Insight, a web-based survey platform. And the idea here is about providing widespread access to this data to clients, to their supply chain, to their contractors, and providing that over the web so that actually you've got lots of people working from the same data set. And that means that can be used as part of a tendering process. It can be part of collaborative design reviews from one organisation to another. And it means everyone is working from the same information. And it might well be that reality capture data is not necessarily enough information, though. We might want to start developing a model off the back of that. We might want to increase the maturity. So at level 1, we talk about modelling and incorporating 3D information. Obviously, 3D information is not one thing. There are different levels of development, and you can see the levels of development broadly speaking illustrated there on the right-hand side. But what we need to have and what we demonstrate is a targeted model development strategy. So recognizing that modeling itself can be a very expensive process and a very lengthy process, and might not necessarily in all cases be worthwhile. And Simple Graph here shows the idea of the quality of information versus the effort. The idea that the raw point cloud on its own is high quality information. It's accurate. It isn't missing anything. There aren't any assumptions, and it's low effort. You go on site, you capture it, and you're done with. You don't need to do anything else. But there are situations in which we want to append metadata to that and add in extra information. So can we do things like point cloud grouping? So we're adding in sections of point clouds where we can say that this area here is potentially a concrete slab, or this area here is a section of pipe work. And it's quite a simple assumption. So you could argue that that's lower quality, but it's still quite low effort to group that so you can append that metadata. We can then move up and increase the quality and increase the effort by doing things like automated feature extraction. So can we add in, can we use some of the tools that exist out there to automatically pull out walls, pipes, floors, those kinds of things, and build up a more substantial model? And then the idea of manual model development. Now, this is the process of getting people to sit down and create 3D models from the old 2D drawings, but also from the point cloud data. But the problem that you often find here is that this could be the largest part of your process. It could take many weeks, many months in order to do this. But at the end of the day, you have a 3D model which maybe doesn't give you any more information than your point cloud. It's only when you start to incorporate more information that becomes valuable. And so we need to be targeted about how we do our model development. And that extra information that is added in is the idea of what comes in at level 2 of digital twinning, so the metadata. And that can be all kinds of things. It can be asset tags, materials, quantities, dose information, and it can also be things like timescales and sequencing. And those timescales, sequences, costs, spend profiles are what are used for the 4D simulation that I'll talk about in a moment. And it's key as part of doing all of this that is done in an appropriate manner, and therefore using standards such as ISO 19650 for managing building information is absolutely fundamental for making sure that this information is communicated and structured in the right manner, and therefore can be shared between different organisations and matches up so that standards are the same across different organisations. So we take that simulation, we take that information from the metadata that we talk about before, the timescale, sequences, costs, those kinds of things. We might add that to the 3D geometry, however developed that might be, whether that's a full 3D model or whether that is just a kind of zoned point cloud or something like that. And we can add those bits of information together to create a 4D plan. And that 4D plan enables us to visualize the activities that are going to take place over the course of the decommissioning process. And that means that it's an easier tool to use for the planning process, better stakeholder engagement, and remove some of the misunderstanding that may exist. Makes it much easier to visualize and optioneer what the possible solutions are to doing decommissioning and dismantling. So let's say we finish at the end of level 2 and we don't decide to go any further with our decommissioning digital twin. But what we need to understand is that all of this needs to be brought together as an integrated digital platform. It's all very well and good that we might have some point cloud data over here and a CAD model over here and some information for on the schedule over here, but actually bringing that information together, creating repositories for all of that data in a unified place is really valuable for being able to provide, again, clients, being able to provide the supply chain and contractors all of that information and access to that information so that we can do better tendering, we can do better planning, we can understand exactly the current state of plant and determine what the next best actions are for undertaking decommissioning and dismantling. And that integrated digital platform could take many forms. It could be custom built, as I will show you some examples of in a moment. It could include multiple different software packages that are all integrated to work together with seamless data transfer from one to the other. And it varies on a case-by-case basis what the most applicable tool is there. But the idea of an integrated platform is key. And what that provides the benefits of is all different kinds of things at the different levels of maturity. So we can provide virtual site access. Can we give people access to nuclear power stations, which are often located in disparate areas far away from population centres, or potentially people from other countries and other regions? Can we provide them remote access to sites so they don't need to go to site using the reality capture data? Can we use a combination of model data and reality capture information to do immersive project reviews? Can we use things like virtual reality and shared immersion in order to improve our decision making and more quickly optioneer solutions? Can we identify hazards and better represent them using dose mapping and overlaying that onto information? And then use the information for project planning, optimizing based on the information that we've got. And again, choosing different options. And then once we've gone through the planning process and we're actually into decommissioning delivery, can we continue to use the data that we've generated, that digital twin that has been created using all of those different data sources to help support during decommissioning whilst dismantling is taking place, so that models can be updated, so that schedules and other information can be updated, and we continuously monitor and improve as we go along. And that's all through what we need to use an integrated data platform, whatever form that might take. That is the theory behind it. there are a few examples where we've done this that I just want to showcase to you, amongst other ones, and these obviously all take different forms, but the idea being of that combination of kind of the level naught information of reality capture data, the level 1 information where we've maybe gone in and done some extra modeling as well and incorporated that and turned that into a simulation in that sense. And we can see one here that's being visualized with virtual reality, so that we can do some planning of operations and understand what the configuration of the site is going to be like. And then adding in that metadata as well, so that we can start to do extra information and add in plans, add in packaging and waste quantities, add that in to do various bits of assessment. And again, all of these tools, we've looked at the idea of the immersive environments that we can create in VR, but can we provide that virtual site access that we talked about before from our digital twin integrated platform, using things like augmented reality to do virtual walkdowns? And that is that's an overview of where those go. And then can we use that for doing full-on simulations of training, investigation, rehearsal and control of completely new proposed facilities or new proposed stuff, where in some decommissioning contexts we might be needing to construct new facilities and therefore test these operations entirely remotely. So with that, I think that's a fair overview of what I want to talk to you about today. But I'm keen to hear any questions that you might have about an integrated platform for decommissioning.
Okay, thank you very much, George. I have a personal question. In fact, it is very similar to the one I raised to Albrecht before. Do you think this kind of tool could be used for better communication with the regulator, the authority? For instance, we could imagine to perform the virtual safety files, virtual inspection by the regulator, and so on. Because anyway, in France, the relationship with the regulator is based on very classical files, paper files, and we do not use this kind of tool for this. In fact, the discussion with the regulator is generally a case of a source of delay in the project, because it takes time to answer to. Probably it could improve the aspect of the schedule of the project.
Yeah, I think that use case, communicating with regulators and other stakeholders is probably just as important as the engineering context, and absolutely it should be able to, because at the end of the day, people like seeing visual information, they like seeing models, they like seeing what the site looks like. And actually, maybe we're providing a lot more context if, instead of saying there is a crack in a certain location on a building and therefore we need to substantiate why it's acceptable to continue, if we can, in that report that we write to indicate that there is an issue, we can link out to some data, and you can see a 360 photo of what that area looks like, and you can then see the model, and the model shows you what that crack looks like, and then maybe that ties in with a simulation that shows how that area is going to be unaffected as you do your dismantling. Then absolutely that's a useful tool for doing that. And added to the fact that often it might be that regulators won't necessarily want to travel to site on a regular basis. They won't want to be there constantly. So providing that remote access to site for them to say you can do a virtual walk down or a guided virtual walk down, absolutely.
And in fact, this point is linked to the question of Jean-Bernard. How do we explain nuclear industry can be slow for adopting digital and data management practices in D&D? What are the main obstacles?
Good question. I think cybersecurity is probably the one is at the top of most people's list of obstructions and the reason that people don't want to adopt things. I think that there is a perceived hazard around how do you do some of this stuff safely? How do you use web-based platforms for sharing information that is potentially nuclear sensitive? We have found that has been one of the hardest barriers to overcome. But actually, there are solutions. Often, cloud-based providers are more secure than stuff that is on-premise, and that is a misconception. So security is probably one of the biggest obstacles. But also, I think that it's not just nuclear decommissioning and defueling. I think that probably all construction and engineering organisations can be slow to change, and I think that's probably something for all of us to take away and understand why that might be and how we can use these solutions.
Okay, thank you. We have also a very practical question. What is the practical use case for using force feedback, for instance, Virtuos 6D interface, what we saw on the last on the slide of your presentation?
Yeah, I think that there's absolutely a use case for using sort of haptics and force feedback for that kind of stuff. So that is that particular last slide that you saw is the idea of a remote hand operation. So removing human hands from glove boxes on operational sites where ordinarily workers would stick their hands in and do whatever they need to do. And actually, we don't need to put human hands in a risky environment there. Can we use robotic manipulators that are controlled virtually, maybe with virtual reality goggles as well to control? And you can easily see how haptic feedback, the ability for the operator to feel what it is that they're picking up or chopping up, is going to make those operations easier and safer and potentially less likely to damage whatever it is you're picking up because you're applying too much force. So is there a role for sort of 6D or that kind of haptic feedback? Yes, definitely.
Okay, thank you. Another question, what lessons have been learned? What would lead to change in ITGR reactor design?
I think there's probably loads of lessons to be learned. I think that one of the thing that is at the heart of all of this is information management. I think that working with decommissioning facilities or facilities that are 50 or 60 or more years old, knowing that those records go missing and we don't have accurate, up-to-date information, and information is not structured correctly, I think that we need to learn the lesson from that. Unfortunately, I think we're probably in a situation where over the course of the last 10 or 20 years, lots of digital information has been created, lots of models, lots of emails, lots of 2D drawings, but perhaps our information management hasn't caught up. And so therefore, we're going to be dealing in another 30 or 40 years time with lots and lots of information which is badly structured, and that's going to really make it more difficult to decommission future facilities, whether that's a high temperature gas reactor or new PWRs.
Okay, thanks. Another question from Albrecht. Have Atkins developed any tools to be applied to a range of D&D challenges?
Yeah, I mean, part of what you've seen as part of this presentation, so the ability to provide virtual site access is a product that Atkins have developed via our Cirrus Insight web platform. There are robotics applications where you've seen that robotic arm that's being used in glove boxes. That is an application, a product that Atkins have developed to be used in these kinds of decommissioning challenges. And there are a variety of other things as well that we're trying to deploy in this environment. Okay.
Another interesting question. There is a cost to acquire the data, but also a cost to maintain the data up to date. How do you evaluate the cost for data acquisition and data maintenance when doing the BC case to choose the right data depth for the project?
Yeah, it's a good question, but I suppose if you use I think it's Moore's law, isn't it, which is that data the size of data doubles every 2 years or something to that effect. So data storage is continuously getting cheaper and cheaper, and by using cloud-based data providers like Microsoft Azure or Amazon Web Services, what we're finding is that actually that cost of maintaining data, or at least maintaining a large amount of data, is less expensive than it used to be, and is substantially smaller than the cost of capturing it in the first place. But yes, there is also a challenge around maintaining that data being up to date. So the idea that actually it's great that we go in and that we potentially do a laser scan or a 360 survey 1 year, but 5 years later that might be out of date. And I think that organisations have got to commit themselves to capturing that information on a regular basis, and that includes when doing large scale design. Do we capture information before we do the design, and then once we're finished, do we capture that information afterwards to change what the plant state looks like?
Okay, thanks. You have also a question from Eric. Which software environment do you use for immersive simulation, VR, AR?
Great question. I mean, there's loads of things out there. Nothing is perfect. So for virtual reality, there are lots of operators and lots of suppliers out there who are starting to offer these things. Autodesk, who lots of us will do our design through Autodesk Inventor or Autodesk Revit. They've got their own built-in virtual reality applications now, which makes it substantially easier to do those things. And then there are similar organizations that do that for augmented reality and things like the HoloLens. But what we often find is that the size of the data that we're working with and the complexity of the models that we're working with are too big for lots of these applications. So in many circumstances, we're having to custom build these applications using some of the latest gaming engines and things like Unity and Unreal in order to create those applications. I think that's the case for now. I think that in 2-3 years' time, organizations will have caught up, and therefore we will be able to use off-the-shelf tools more regularly, and I look forward to that. But for the time being, it's custom built.
Okay, thank you very much.
Thank you.
I think that's all for the questions. So thank you very much, George. Thank you also to other speakers from today's session, Beranger, Albrecht, Paola. Before the conclusion word by Valérie, I just would like to remind you that there is a tech demo available on the mobile application. You can have access at your convenience. So, Valérie, I would like to introduce Valérie Faudon, the president of the French Society of Nuclear Energy, for the conclusion word of the conference. Valérie?
Thank you very much, Eric. I hope you hear me well. So I wanted to thank everyone for your participation in Index. You were 1,200 attendees from 40 countries to take part in at least one of the 18 live sessions over these past 2 months, whether you attended panels, keynotes, case studies, or tech demo pitches. And we have welcomed on this stage more than 70 speakers to talk about the future of the nuclear industry. Some key takeaways, but I think we'll have to debrief further from this Index edition, is that now digital continuity has become a real practice of our industry. Digital standards in nuclear are key for us to accelerate applications and platform deployment. New developments in AI are questioning safety authorities, and in general, digital transformation is questioning safety authorities. Data is a foundation for learning industry. So don't hesitate to watch the replays, share them widely around you so you don't miss anything that was presented. I would like to thank really our president for the program committee, Jean-Bernard Thévon, who is also the president for the technical section number 16, which is digital transformation in nuclear at the French Nuclear Society, but as well as all the program committee. So I have the name here. So Claude Duval, Jean Ders, Guillaume Montandon, Antime Farda, Patrick Moria, Sébastien Daz, Philippe Derycke, Éric Cantrel, Bertrand Lépinois, Jean-Pierre Durand, Jean-Eudes Guillot-Godefroy, David Rouf. Merci à tous. Thank you very much because you did a wonderful job. And I think this conference has been very successful, and thank you for your hard work. So we have built through this conference a community of 1,200 professionals, as I said, from 40 countries, and we want to continue to exchange on the subject. So that's why our technical session will continue to propose events, documentation, in particular on artificial intelligence in the nuclear industry, but also on all the cutting-edge topics. So I guess we'll see each other soon. Thank you very much.